Here's the question that I want to explore today. Can ChatGPT get a question in written text and convert that into SQL to answer the business question correctly? So think about a simple example. Suppose that I need to figure out what's the revenue of my company, and I want to ask ChatGPT, hey, what is the revenue of my company last year? And ChatGPT convert that question into SQL code. Maybe it's like select some revenue from table, revenue group by year, where year equals 2024, right? So those types of questions, it's what we think of them as converting text, plain English, to SQL statements to answer business questions. Now, the answer is yes. ChatGPT can do that, with the caveat that to some degree. So this video is going to be exploring what does it mean to some degree. Obviously, the question that I mentioned is pretty simple, and it's something that ChatGPT would be able to do, or any other LLM, LLMs like Llama and the like. But the nuance is, okay, like what about like a slightly harder question, or what about a very hard question? And I'll also give you my points of view and the like, but I want to start by sharing two research papers. So actually, the first paper that we want to take a look at is, can LLM already serve as a database interface, big bench for large-scale database grounded in text-to-SQL? So the interesting thing about this paper, it's I'm going to scroll all the way down to a table that they have, and which we want to get to the point, to the actual, we want to understand like the actual results that we get, not necessarily the details. So so the table that we want to focus on is this one. Basically, what this research did is they use one of there's academic models that you can, that literally what they do is they contain a lot of questions and SQL pairs with particular database schemas. So you have the tables, you have the questions, and they get converted to SQL by researchers, right, or by analysts, right? So that already exists. But then what this research paper is doing is it's taking that particular metric, that particular data set, and it's applying it to different variations, right? So the first interesting one, that I would highlight is ChatGPT 4. There's a couple other models here. To be honest, this video is less about who's the best one. Like I don't care. Like there's also GPT 4.0 that came after GPT 4 and the like, that has better improvements. I care less about the particulars of the model, and I care more about explaining where technology is at today and what to expect. Anyway, so for that particular reason, we're gonna focus mostly on GPT-4. But you can see here that Claude was trailing GPT-4. Newer versions of Claude got better and the like. So again, this is not a comparison. But what is important to mention here is that without any knowledge of the database and the like, just taking the question and producing the result, you get 30% accuracy on correctly generating or correctly translating text to SQL. So basically, think about it this way: for each 3 questions that you ask ChatGPT about your database, at best, you can expect 1 to be correct, right? So the question that I mentioned, about revenue, blah blah blah, it's going to be correct, perhaps on the first try. The other 2 questions that I ask, maybe they're variations, right? And maybe they're slightly more complex. Those are going to be incorrect. Now, the other thing to consider is that this is an academic benchmark. What we've seen in the real world is that some databases are, or some problems are actually simpler than these academic benchmarks, and some databases in the real world could actually be much harder. And same for the questions. The questions were generated by researchers, and even though they try to be as generic and rich as possible, what we've seen in practice is that you can have like a very complex database, but also have expectations from your business users that are, that require very simple answers. That could still, get you above the 30%, right? Potentially. So what I'm trying to say is that this is just a benchmark or a particular set of databases with a particular team that, creating the test cases for, for this particular case. What we've seen on the real world is like there's much more variation, and I'll get into that. But it is important to notice that from this paper, your expectation, and again, this is academia, but your expectation would be that if you connect your database to ChatGPT, you get 1 out of 3 questions correct. That's interesting, and I think it has a lot of business implications of how you use ChatGPT. What expectations do you set to your team? Is it a replacement to a data analyst, or is it like like a temporary solution while the data analyst comes up with the actual report, right? Like, or is it like an aid for the business, for the data analyst and the like? From my point of view, the way that I look at this is this 30%. We're going to look at the improvements, right? This 30% is still pretty amazing, and it's a tool worth using in your organization. Now, here's the comparison. So if you look at human performance, so human performance has about 92.96% accuracy. So the important things to notice here is, first of all, even people make mistakes, right? So when you ask if you're a business user and you ask your data team, what was our revenue in 2024? There's still a risk that they're going to make a mistake and they're going to give you the wrong revenue. Now, there's, obviously people more experience in the data set and, processes and existing dashboards and the like, can reduce this close to 100, right? Like if you already asked the question and it's a question that has been used in the past, it should be closer to 100% because someone already assessed that dashboard and the like. But the reality is that even people make mistakes. And in this particular data set, what they measure is that a person is as good as 92.96% accuracy. So from my point of view, if I'm a business user, it has a lot of value even to be able, to have 1 in 3 answers correct when I ask a data question, compared to 9 out of 10 being correct asking an expert. Now the question is why? Well, it comes really down to availability and basically availability, right? So when as a business user, I ask a question to my data analytics team, you never get a response in under 1 minute, right? Like it just doesn't work that way. When you send the request, you need to wait for someone to take it. They have a work item, best case scenario, maybe you get a reply in a few hours. Worst case scenario, you never get a reply, right? Or it takes months. So the variability of service that you get as a business users from your data analytics team, can be mitigated by teams like by solutions like use ChatGPT connected to a database. So that's the first insight that I get from here. Now, the other important thing to notice just from this table is that you can't rely on the answers being correct. 1 out of 3, is much worse than 9 out of 10 being correct. So as a business user, in the same way that when you ask ChatGPT, who's the president of United States, right? Hopefully you get the right answer, but elections just happened, and depending on which model you ask, the model might not be up to date, and the answer might be wrong, and you might be getting data from the past year. So I have a full video on kind of like how to use ChatGPT and the like. Feel free to watch that. But my point of view is that as long as a business user, you understand the caveats of this system and you understand like, hey, I'm only getting 1 out of 3 questions correct. I need to be very deliberate in verifying my answers, right? Like, so instead of asking, what is our revenue last year, perhaps the question that I want to ask is, what has been our revenue the last 5 years. And then as a business user, I might know the revenue on 2022 and 2023, but I don't know the revenue on 2024. So that would help me understand, is the answer correct, right? Because I have 2 data points that are telling me that this is actually accurate and is doing correctly. Now, the other use case that you can use is to use this system for exploratory data analysis, right? So suppose that I tell you, hey, you have an AI expert. You have this AI expert that is good at writing data analytics questions, but it's only gonna be correct 1 out of 3 times. You can use this very efficiently for optimizing your marketing campaigns, right? And the way that you can think about this is like, hey, let me go and find information about my marketing campaign that I might not be aware of. So you can ask a question like, hey, which campaign is doing the best, right? And like you're gonna figure that out, right? And you're gonna say then, when did we see a spike, right? It's like, oh, this date. Like, oh, interesting. Like where do the users came from? Oh, from mobile. So now you've been doing exploratory data analysis that then you can use to validate, correlate with your knowledge. So suppose that it tells you like, hey, on January 1st, 2024, you had a spike of 40%. Now what you can do is think, oh, yeah, that is actually really interesting. I'm gonna go and see what post we did in that particular day or the previous one, right? And, you would use that information to figure out insights that are very relevant to you. And, even if 1 out of 3 cases, like you go through that path and you find out like, oh, nothing happened on January 30th, right? Or whatever. And, like, yeah, you wasted some time, going through that path and doing exploratory data analysis on the path that was not correct. But on the other side, you were self-sufficient. You were basically self-sufficient answering those questions, and either ChatGPT or the integration allowed you to answer questions that perhaps weren't as useful to do before. Now, we're looking at this as the worst case scenario, 30%. That is pretty bad. What I want to cover on the rest of this topic is like, how do we get from 30% to ideally 90%? And obviously, technology is not there. That's the that's the short answer. Currently, if you need like a proper reply, it's best to go to your data team. But if we can move from that 30% closer to the 90, and maybe that means 60% or 70%, and maybe for some particular questions, for very specific use cases, we can get even beyond 92%. So what is the art of getting there, and how do we do that? All right, so the first improvement that we can go from 30 to 46%, it's to provide context. So what context and what knowledge is, you can look at the research paper and figure out exactly what they did. But in my experience, we're working with customers. If you give us a database and we want to answer those types of questions, what you want to do is you want to understand, first of all, the database, what tables are there, what columns, what are the data types, are there any views that we can reuse that already aggregate the data, what is the business context around this, et cetera, et cetera, et cetera. So all that additional information that you provide to your LLM, will increase the accuracy. In this particular research, again, it went from 30% to 46%. So now it means, if we round up, now we're saying like only 1 out of 2 questions are incorrect. You're getting close to the 50%, right? So that's pretty great. And, like when you compare it, to an expert, we're getting closer. Now, again, I'm going to keep repeating this caveat over and over again. This is academia, like this is just one benchmark that we're looking at. It could be easier in your case. It could be harder, right, for your database. The questions could be easier. The questions could be much harder. Maybe you already have a lot of dashboards, so the only remaining questions that you have are super hard. It really, really depends on your particular use case. But talking about kind of like this academic research papers and data sets help us understand kind of like where to improve and where to go. Right, so 46% definitely much better. It can get as close as 50% in using a paper or an approach called text-to-SQL. So we'll take a look at that as well. And yeah, so this is just ballpark, estimates and the like. Don't take them for granted of like, hey, I got promised 50% or 55% on the testing data or the like. Rather think of this as, hey, connecting ChatGPT to my database will provide value, but it's not going to be perfect, and I need to find ways of improving it, and I need to ways of adapting my business processes, knowing that the information might not be correct. Now I'll show the other paper and also it's important to talk about what are the things that we can do to get closer to 100%. And if I go back to this table for a second, it's not that hard to get close to 100% if you reduce the scope of the project, right? So, and again, I'm not saying that this is the right use case, right? But if you tell me, hey, I need to make sure that this system replies with 100% accuracy, the way of doing that is to, not recommending you do that, but like you can have the questions that the user might answer hard coded to the SQL answers that the system should reply to, right? That would give you 100% accuracy for very specific use cases. That's not going to be a very useful system because, like basically whenever someone asks a question, someone still needs to write the SQL. But that's part of the trade-off that you'll have to see and you'll have to experience, as you evolve into moving some of your data analytics workflows to use generative AI. It's not, it's not necessarily the right metric to say we want 100% accuracy, because then like it's gonna degrade the value of generative AI. It's also a bad idea to say like, oh well, it's just 30%, like whatever the LLM does, we don't care. It is what it is, because you're also leaving a lot in the table. So let's just look at this paper. It's called text-to-SQL Decomposed in Context Learning of Text-to-SQL with Self-Correction, apparently from the University of Alberta in Canada. And they have a diagram somewhere in here that is worth showcasing and discussing. So there are a lot of things that we can improve. And this diagram is not comprehensive, I would say. We actually developed some of these same intuitions even before the paper was developed. And it's not just us, but many companies that are doing generative AI and integrating with the enterprise and the like, figure out, these concepts kind of like, they do improve the accuracy from that 30% to like, with context and the like to like 55 or, whatever the number was, mostly by being smarter on the way that you are generating the SQL and also adding a workflow that can increase the accuracy, right? So for instance, one of the most important use cases that is worth incorporating into your workflows is what is called self-correction. And self-correction is really nothing more than running the query, and really understanding, hey, are there any errors, right? Or just looking at the query and asking the LLM, hey, are there potential problems here? Can you improve it? To us, like, we would highly recommend that the queries are always run before the user gets the results. So that way the LLM has time to validate that the results are correct. If there's an errors, they can get improved. If no rows are returned, like that might be a case where you want to rerun it or revalidate, like, hey, this is not returning any rows, how you can improve it and the like. Anyway, so this particular paper, like they have their own point of view on how to generate SQL. I think to me the most important part of this paper is the self-correction mechanism. But there's many additional use cases and techniques that you can incorporate while generating your SQL statements to get closer to, say, maybe a 70%, right? Or even a 90% if you scope the solution. I'm not gonna list them all, but I wanna keep this video generic on general techniques. We talk about self-correction. Another one that I would throw there is generating views. So many times you can increase performance significantly by not looking at the tables and having to get the LLM to generate the joins, but rather have your technical team, your data analytics, build those views with the data that is already aggregated and ready for a large language model to interpret it and the like. Adding context, for your business, for your database and the like, super useful. That's one of the other things that would highly recommend. And then the last area that, it's a little bit more up and coming, but using agents, an agent framework. I might do a video just on agents, but you can think of an agent as several different steps coordinated for a workflow of improvements that are applied to large language model task. So rather than just saying, hey, generate SQL, you can break down the problem into different subtasks and potentially assign them different agents that have particular tasks, right? So you could do something like, hey, the user wants to know what was the revenue last year. Your task is to understand better the question. That could be one agent. And then another one could be, hey, your job is to write SQL statements. Okay, that's great. You can have another agent that says like, hey, your job is to take a look at the SQL statements that are generated and making sure that they're performant and that, are not unbound and could return too much data, right? And the like. And then you can have like the self-correction agent that is looking for errors and fixing it. You can look at the one that takes the context and improves it and the like. Now, from my point of view, like each project at this point in time, it's different and it makes sense to look at, hey, how does your database look like? How can we improve it? And more importantly, even before you improve it, is my suggestion would be just connect your database to ChatGPT, right? And understand what's your baseline. We go back to this baseline that we had here. It would be super important to understand if your baseline is 30%, or maybe you're at 3%, right? Like I've seen some very complex SQL graphs or databases with a lot of relational data and the like, nested structures. I know maybe when you connect ChatGPT directly, you don't even get a 30% accuracy, right? Like maybe you're down to like 3% or maybe 0. So, like it's very, on the other side, like, maybe you're connecting to your database and you already have views. And when you connect them, if you connect them just to the views, maybe you're close to like a 70%. So it's really, this data and this numerical expectation is very particular to your own questions and your own database, right? So you want to, as fast as possible, connect ChatGPT to your database and understand how far along is ChatGPT or whichever LLM, Gemini, Claude, Anthropic, Llama, or the like. How far is the LLM from understanding your database, right? And then have a conversation with your business users. It's like, hey, we did this test. Like these are the types of questions that it can answer. Do you see any value there? Do you want to test drive it? If you start those conversations way earlier in the cycle, you're gonna start building more successful generative AI projects within a budget that is reasonable for the value that they provide. Yeah, so I'll leave it at that. Hopefully this video was useful. If you have any questions, you can find me on LinkedIn, Twitter, X, and YouTube and the like. Thanks for watching. See you around.